Hello everyone. Hello everyone. Today we shall discuss with playing with numbers, chapter 16. Let us find what is given in playing with numbers. Here you see, there is an introduction here. You have studied various types of numbers such as natural numbers, whole numbers, integers, and rational numbers. You have also studied a number of interesting properties about them. In class 6, we explored finding factors and multiples and the relationships among them. In this chapter, we will explore numbers in more detail. These ideas help in justifying tests of divisibility. Numbers in general. Let us take the number 52 and write it as 52, 50 plus 2, that is 10 into 5 plus 2. Similarly, the number 37 can be written as 37, 10 into 3 plus 7. In general, any two-digit number AB made of digits A and B can be written as AB is equal to 10A plus B or 10A plus B, and B is equal to 10B plus A. Let us now take number 351. This is a three-digit number. It can also be written as 300 plus 50 plus 1, or 100 into 3 plus 10 into 5 plus 1 into 1. 497, 100 into 4 plus 10 into 9 plus 1 into 7. Or ABC can be written as 100A plus 10B plus 1C. 100A plus 10B plus 1C. CAB can be written as 100C plus 10A plus B. And BCA can be written as 100B plus 10C plus A. And so on. Games with numbers. Reversing the digits two-digit number. Meenakshi asks Sundaram to think of a two-digit number and then to do whatever she asks him to do to that number. Their conversation is as shown in the following figure. Study the figure carefully before reading on. Conversation between Meenakshi and Sundaram, first round. Meenakshi, choose two-digit number. Alright, chooses 39. Reverse the digits to get the new number. Okay, I will get 94. Add this to the number you started with. Yes, it gets 143. Add this number to the number you started with, that is 143. And divide the answer by 11, gets 13. There won't be any remainder. Yes, you are right. But how did you know? It so happens that Sundaram chose the number 49, so he got the reverse number 94. Then he added these numbers 49 plus 94, 143. Finally, he divided this number 11. 143 by 11 is 13 with no remainder. This is just what Meenakshi had predicted. Now let us see if we explain Meenakshi's trick. Suppose Sundaram chooses the number AB, which is short form of two-digit number 10A plus B. On reversing the digits, he gets the number 10B plus A. When he adds the two numbers, there is 10A plus B plus 10B plus A equal to 11A plus 11B. So the sum is always a multiple of 11, just as Meenakshi had claimed. Observe here that if we divide the sum by 11, the quotient A plus B, which is exactly the sum of the digits of chosen number AB. You may check the same by taking any other digit number. The game between Meenakshi and Sundaram continues. Again, think of now another two-digit number, but don't tell me what it is. Alright, now reverse the digits of the numbers and subtract the smaller number from the larger one. I have done the subtraction. What next? Now divide your answer by 9. I claim that there will be no remainder. Yes, you are right. There is indeed no remainder, but this time I think I know how you are so sure of this. In fact, Sundaram had thought of 29, so his calculation were first he got the number 92. 92 minus 29, 63, and finally did 63 divided by 9 and got 7 as quotient with no remainder. Let us see how Sundaram explains Meenakshi's second trick, and now he feels confident of doing so. Suppose he chooses the two-digit number AB, 10A plus B. After reversing the digits, he gets the number 10B, BA, that is 10B plus A. So now Meenakshi tells him to do a subtraction, the smaller number from the larger one. That is 10B, 10A plus B minus 10B plus A, 10B, that is 10A plus B minus 10B minus A, or 9B, 9A minus 9B, 9 into A minus B. If one's digit is larger than the tens digit, if B greater than A, he does 10B plus 10A minus 10A plus B, that is 9B minus A. And of course, A is equal to, if A equal to B, then he gets 0. In each case, the resulting number is divisible by 9. So the remainder is 0. So observe here that if we divide the resulting number obtained by subtraction, the quotient is A minus B or B minus A, according as A greater than B or B greater than A greater than B or B greater than A. You may check the same by taking any two other digit numbers. Reversing the digits, 3-digit number. Now it is Sundaran's turn to say play some tricks. Think of a 3-digit number, but don't tell me what it is. Alright, now make a new number by putting the digits in reverse order and subtract the smaller number from the larger one. Alright, I have done the subtraction. What next? Divide your number answer by 99. I am sure that there will be no remainder. In fact, Meenakshi chose the 3-digit number 349, so he got reverse number 943. Difference is 943 minus 349, that is 594. Division 594 divided by 9 equals 6 with no remainder. Let us see how this trick works. Let the 3-digit number chosen by Meenakshi be ABC, that is 100A plus 10B plus C. After reversing the order of the digits, he gets the number 100C plus 10B plus A. On subtraction, if A is greater than C, then the difference between the numbers is 100A plus 10B plus C minus 100C plus 10B plus A, 100A plus 10B plus C minus 100C minus 10B minus A, or 99A minus 99C, 99, that is C A minus C. And if C is greater than A, then the difference between the numbers is 99 C minus A. And of course, if A is equal to C, the difference is 0. In each case, the resulting number is divisible by 99. So the number is remainder is 0. Observe that the quotient is A minus C or C minus A. You may check same by taking other 3-digit numbers. Forming 3-digit numbers with given 3 digits. Now it is Meenakshi's turn once more. Think of any 3-digit number. Alright, I have done so. Now use this number to form a 3-digit number like this. If the number if choose is ABC, then the first number is CAB with the ones shifted to the left end of the number. The other number is BCA with the 100 digits shifted to the right end of the number. Now add them up. Divide the resulting number by 37. I claim there will be no remainder. Yes, you are right. In fact, Sundaram had thought the 3-digit number 237. After doing what Meenakshi had asked, he got the number 723. 723, then 32372. So he did 237, then 723, then 372. If we add 1332, then he divided the resulting number by 37. He got 36 with no remainder. Right? In this way, you'll find that here the trick is ABC A 100A plus 10B plus 10C, CAB equal to 100C plus 10B plus B, and BC equal to 100B plus 10C plus A. Then if we add the numbers A 111, A plus B plus C, and 37 into 3, A plus B, which is divisible by 37. Right? Letters for digits. Letters for digits. Here we have puzzles in which letters take the place of digits in an arithmetic sum, and the problem is to find out which letter represents which digit. So it is like cracking a code. Here we stick to problems of additions and multiplication. Here are two rules to follow while doing such puzzles. Each letter in the puzzle must stand for just one digit. Each digit must be represented by just one letter. The first digit of a number cannot be 0. Thus we write the number 63 and not as 063 or 0063. A rule that we would like to follow is that puzzle must have just one answer. Find Q in the addition like this. The solution is like this. There is just one letter Q whose value we have to find. Study the addition in the ones column. Q plus 3 we get 1. So that is a number whose ones digit is 1. For this to happen, the digit Q should be 8. So the puzzle can be solved as follows: 8, 19, 11. That means 8. This is also 8. 5 and 1. That is the answer of Q is 8. Find A, B in the addition like this. BA. This has two letters, and B whose values are to be found. We study the addition in the ones column. The sum of A is 3A's is a number whose ones digit is A. Therefore, the sum of two A's must be a number whose ones digit is 0. This only happens for A equal to 0 and for A equal to 0 and A equal to 5. Right? So if A equal to 0, then the sum is 0 plus 0 plus 0, which makes B equal to 0, 2. So we do not want this, as it makes A equal to B. And then 10 10 digit of BA, 2 becomes 0. So we reject this possibility. So A is equal to 5. Then we are getting 5 plus 5 plus 5, that is 15. That is A equal to 5, 5 and B equal to 1. Find the digits A and B. BA into B3, that is 57A. Right here you can find that is the value of B is 2. 25 into 23, that is 575. Right? Next we'll do the exercises. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.